All right, greetings and salutations, young true believers. Welcome to week 2, critical thinking. So, today we're going to talk about two kinds of arguments. Um, Very broadly speaking, when human beings are thinking rationally, we obviously have an emotional side, and we'll talk about that in a few weeks. Um, we're thinking along two very broad lines, right? There are two principal styles of reasoning that we engage in. So the first one, or the first style, is known as deductive argumentation, right? So, what is typical of deduction? The conclusion of a deductive argument is proven or demonstrated beyond a reasonable doubt, right? Bottom of page 34 of the Moore and Parker text, they write, the premise or premises of a good deductive argument, if true, proves or demonstrates its conclusion, right? So an example of a deductive argument would be one you were familiar with since the time you were 5, 2 plus 2 equals 4, right? Now, deduction has there are two associated concepts with deduction, and we're going to talk about the first one, validity. So a deductive argument is valid if it isn't possible for the premise or premises to be true and the conclusion false. Now, that sounds really complex. It's not. And here's the example from the text. Premise: Jimmy Carter was president immediately before Bill Clinton, and George W. Bush was president immediately after Bill Clinton. Therefore, Jimmy Carter was president before George W. Bush. All right. Now, as you can see, it's impossible for these premises to be true and its conclusion to be false, so the argument is valid. You may have noticed that there's a mistake, however, in the premises, because Jimmy Carter was not president immediately before Bill Clinton. Immediately before Bill Clinton, it was George H.W. Bush, and then before him was Ronald Reagan. Nevertheless, even though a premise of the preceding argument is not true, the argument is still valid because it isn't possible for the premises to be true and the conclusion false. And another way to put this is, if the premises were true, then the conclusion could not possibly be false, and that's what valid means, right? Now, logicians, as a general rule, are very interested in validity. They're not interested in the second concept. The second concept is soundness, right? When the premises of a valid argument are true, there's a term for that, and that's soundness. A sound deductive argument is a valid deductive argument with true premises and a true conclusion. Here's an example. Bill Clinton's taller than George W. Bush. Jimmy Carter is shorter than George W. Bush. Therefore, Bill Clinton is taller than Jimmy Carter. That's a sound deductive argument. All sound deductive arguments are also valid deductive arguments, but some valid deductive arguments are not sound deductive arguments. All right? Validity and soundness are extremely important concepts, but as I mentioned, logicians are only interested in the former. They're not all that interested in the latter as a general rule. Why, then, are they so interested in validity? Because in order to ascertain whether or not a given deductive argument is valid, all you have to do is look at the form of the argument. Now, that's going to make a lot more sense when we get to chapter 9 of this course, and you'll see what we mean by just looking at the form, right? All right, well, what about inductive reasoning? Induction is the other big primary form of reasoning that human beings engage in. So what is induction? The conclusion of an inductive argument is never proven or demonstrated. It is only more, in which case it is a strong inductive argument, or less, in which case it's a weak inductive argument, probable. Induction trades in probability. Now, this isn't in your text. I just want you to know this, FYI. An inductive argument with true premises is what's known as a cogent argument. Induction is absolutely indispensable for the success of science, right? Why is this? Well, let's say you observe a crow today. The crow's black. And over the course of the next 6 months, you literally observe 1,000 crows. You may be tempted to come to the conclusion that all crows are black, right? That's the purview of science. We're going from particular observations to generalizations, and inductive reasoning allows us to do this. Here's a classic example of an inductive argument from the great Scottish philosopher David Hume. Premise: the sun rose today. Conclusion: therefore the sun will rise tomorrow. Now, this is not in your text, but again, I want you to know this. David Hume pointed out there is a problem with every single piece of inductive argument. Ironically, however, even though there's this major problem that Hume talked about, and I'm going to describe for you in a second here, we can't dispense with it because we cannot engage in modern scientific reasoning without inductive reasoning. It's science depends for its success on inductive argumentation. So what's going on? Hume notes between that first that premise, the sun rose today, and the conclusion, therefore the sun will rise tomorrow, there's an enthymeme. What's an enthymeme? An enthymeme is a hidden or suppressed premise, one that is not overtly stated. You have to infer it. Okay, well, what is this enthymeme, this missing premise? This enthymeme in this particular argument and in all inductive arguments is as follows: the future will resemble the past. There's a problem. The future will resemble the past is not rationally justified because we don't know the future and we cannot know the future. The absolute most that we could say is, again, that it's highly likely that the sun will rise tomorrow, but we don't know that. We can't know that. We're not time travelers. We're not God, right? So, induction, controversial. Many philosophers and mathematicians and scientists have tried for the past 250 years since Hume wrote those words to show that he got it wrong. They can, right? But we can't dispense with induction either. One more example of an inductive argument. After 2 p.m., the traffic slows to a crawl on the Bay Bridge, the San Mateo Bridge, the San Rafael Bridge, and the Dumbarton Bridge. Therefore, it probably does the same thing on the Golden Gate Bridge. Now, this is a strong inductive argument. How do you know it's strong? Well, all 5 of the aforementioned bridges are in the Bay Area, right? They're here at home, and if 4 out of the 5 are jammed up after 3 p.m., it's a safe bet that the 5th one is too, right? Doesn't guarantee it, but makes it far more likely, right? All right. Now, how do you tell the difference between a deductive and an inductive argument? All right. I'll give you 2 examples of these to illustrate the difference, right? Here's the first argument. Juan lives on the equator. Therefore, Juan lives midway between the North and South Poles. Here is the second argument. Juan lives on the equator. Therefore, Juan lives in a hot and humid environment. Now, the first argument, you might have guessed, is deductive. As a matter of fact, it's a special kind of deductive argument called a tautology, or a definitional truth. In other words, it's like saying a bachelor is an unmarried man and an unmarried man is a bachelor. It's a trivial truth because those terms are synonymous. So tautologies are, again, the purview of logic, trivially true statement. So if you know what the equator is, you know it's an imaginary line that separates the North and South poles. And if you're standing on the equator, you are exactly midway between the poles. Now, the second argument, Juan lives on the equator, therefore he lives in a hot and humid environment. Well, the area, there are 2 areas adjacent to the equator. They're called the tropics. There's a Tropic of Capricorn, there's a Tropic of Cancer, hence the word tropical. Now, this is the area of the planet that gets the most direct sunlight. When you get a lot of sunlight, you get a lot of plant growth. When you get a lot of plant growth, you retain a lot of water, hence humidity. So this does not prove that Juan lives in a hot and humid environment. He may live, for example, on the top of a mountain, right? Be cool. But it certainly raises the probability that Juan lives in a hot and humid environment, right? So when you're trying to ascertain, and I definitely recommend you guys practice with this. There are plenty of examples of this in the text, right? Am I dealing with an inductive argument or a deductive argument? Ask yourself, is this argument stating definitely this is the case, or is it asking about the probability of the matter at hand? If it's asking about the probability of the matter at hand, it's almost certainly going to be inductive. So on Wednesday, I will be back. I'll talk to you about two styles of reasoning that combine elements of a deductive and inductive argument, and I'll talk to you about Aristotle's three methods of persuasion.